All right, so this is one y'all haven't seen. Sorry, I just want to make sure you have one that has momentum and is one of the 12-point lab setups. Just so you know how to do those. There will be one of these on the test tomorrow, or Tuesday. A group of students has two carts, A and B, with wheels that turn with negligible friction. So it's pretty much just like ideal system sounds like. The carts can travel along a straight horizontal track. So that's probably just going to be like one dimension like that. Okay. Cart A has a known mass of mass A. Wonder what's up with B. All right, the students are asked to use a one-dimensional collision. Okay, so I was right. Between the carts to determine the mass. That makes sense. Determine the mass of mass B. Before the collision, cart A travels to the right. So I guess that means that this is VA. And cart B is initially at rest. So B, that's the subscript B equals 0. All right, because it's at rest. Okay, as shown above, after the collision, the cars stick together. So that's probably going to be, okay, so I've just drawn like before, this one's traveling at this one, it's at rest, and then after, this is A plus B. It makes sense to me. None of this is written where the answer should be, where the answer's supposed to go, so it's all right. This is just kind of my like scratch work. So I'll put V prime afterwards. I've shown that they stick together. That says A and B. And I put question mark. I'm not even really sure it goes that way. They could stop or something if B is really massive. Okay, since they stick together like this, I'm assuming it's inelastic, meaning that the kinetic energy before the collision is not the same as the kinetic energy after prime. So I'm betting that those aren't the same. So it's just kind of my speculation. All right, now here's the experiment part. Describe an experimental procedure to determine the velocities of the carts before and after the collision, including all additional equipment you would need. You may include a labeled diagram on this. No, you not may include a labeled diagram. Guys, you will include a labeled diagram, always. Maybe two different views of your setup to help in your description. Indicate what measurements you would take and how you would make them. That means which tools. Include enough detail so that another student could carry out your procedure. This one's a little weird because the question itself is the students looking to determine the mass of cart B ultimately. But right here, describe an experimental procedure to determine the velocity of the cart before and after. Also, whenever you see the word collision, that's kind of weird with the velocities, but if you think about the word collision, remember that usually has to do with, if you have a collision, you're going to have a conservation of momentum. And all this mass and velocity stuff is probably useful to that because the player with the most momentum in a game is the MVP. But we'd have like, before and after. So let's focus on this right now, the getting the setup done, and then, but we'll probably return to that. Okay, so I have drawn a setup and labeled it setup, and I have not gone into great detail, but I basically have 1, 2, 3, 4 students to help out. This one's giving the velocity to cart A. I have indicated the horizontal frictionless track. I've indicated cart B. I've put tape on the table that's 1 meter apart here. I've labeled this the starting line. I've indicated that's 1 meter apart. I think I said that. I put a long level table. It helps eliminate systematic error. So does the frictionless. All right, these two guys have stopwatches. Guys, avoid using your phone. It is so difficult to describe exactly how to use your phone. Don't say student measures using phone. Just don't even put the word phone in there. Yes, these stopwatches are probably on their phones. Did I say their phones? No, I even drew the old school dial stopwatches. So just say the app that you're using. Don't say your phone. Okay, so I put a long level table. I've left plenty of room on this side. I've left plenty of room on this side. And I've got another student with a sticky note. So let me explain what all we're doing with this. Okay, so now I think I have adequate directions. I added a couple of things to the setup. I'm not sure if you can see it. I added stars where the fronts of the cart were. Note front of the cart is marked with a star in the setup diagram. I also remember they needed to stick together. So if y'all remember what we did in the Hot Wheels lab, I put putty right there. I put putty to make carts stick together. Remember, be careful with terms like ticky-tack and sticky-tack and putty. Make sure you say what they're for. Okay, so here are my directions. Place 2 stripes of masking tape 1 meter apart on the table as shown in the setup diagram. Use meter stick to measure the space between the stripes. Be sure to leave space on either side of the stripes. Okay? Place the students and carts according to the setup diagram. All right. Student 1 applies a force to cart A behind the start line. Let's see. The force should be great enough for cart A to travel 1 meter and to collide with cart B. Student 2 begins timing as the front of cart A crosses the start line and stop timing as cart A collides with cart B. Records time in data table, which I'll draw below in just a second. 5, student 3 begins timing as the carts collide. 6, after 2 seconds, student 3 calls time. Student 2, see I made a mistake right here. Student 4 places the sticky note where cart B's front side, is, I should probably put located when student 3 calls time. Measure and record in the data table below the distance between the front of cart B's starting point and the sticky note. 2 things I forgot here. Well, I'll put begins timing. They have stopwatches, that's okay, but I should put measure with meter stick. I really should have probably just drawn a meter stick somewhere in here. So, spelling doesn't count. Anyway, so that should be good enough for most students to follow. Just remember how it felt for those of you who wrote the directions on your trebuchet and people followed them and it didn't work. Just think about that. Assume that's what you'd have to do on this kind of problem. Alright, so I made a couple of changes. I had forgotten the most important part. Repeat steps 1 through 9 2 more times. Gotta have evidence in multiple trials. That is evident in my data table, but better safe than sorry. Okay, I also changed student 4, 2 to 4. Let's see, so now I have my data table below, so I can indicate a few things. Let's see, place 2 stripes of masking tape 1 meter apart. So right here, I'm going to write that as displacement 1, like I have in the data table. That's supposed to be a subscript 1. And you can see down here, I've put my headings, I put my what I'm measuring as 1. I need to define that up here. And I've put meters here. I didn't put 1 meter, 1 meter, 1 meter. I guess I can go and put the average as 1 meter since everything's the same. Same thing here with 2 seconds. But see, I've subscripted everything and I've put the units. Now I'm going to show where I get it from. So S1, I've indicated I've measured up here. Okay, student 2, and see where I say record the time? I'm going to put this time as time 1. That's important that I'm defining these and not just leaving them as letters. Alright, so student 3 begins timing 2 seconds. So there's 2 seconds right here. I'm going to put as T2. Alright, student 4 places the sticky note, and then measure with meter stick. This part right here, the distance. Or I should have really said displacement, or I could have used D here, but either way, it doesn't matter. I could call it smiley face, as long as I define it. This distance right here is S2. Now, to find this, I'm just going to circle this. To me, this is the most efficient way. For VA, I'm going to put VA equals displacement 1 over time 1. Okay, and for V prime of the 2 parts together, I'm going to put v prime equals displacement 2 over time 2. There you go. And so then I can just calculate that. Where, you know, I can just plug that in and then calculate that. I could state explicitly to go ahead and calculate it, but if I draw these arrows, that should be more than fine.